All right, so same thing. We're continuing this video of 7E for samples and population, but now we're going to just focus on um, the last two parts, which will be the difference between biased and unbiased samples, and then being able to use a sample to make predictions. All right, so we have two different kinds of samples that we can take, and one of them is not valid in us being able to actually use for anything. So if we're actually trying to take a sample, we want it to be unbiased. All right, and an unbiased sample is a representative of a population, and it's selected at random and is large enough to provide accurate data. So when we think of the word bias and unbiased, when something's biased, well, let's just go with it as first. It's not a representative of a population, where one or more parts of the population are favored over others. So when we think of bias and unbiased, what this is just saying is that if we're doing a biased sample, it means that we can't accurately say it describes the population because we might be trying to make sure that we're picking things that will benefit us with our questionnaire or us with our survey or us with whatever we're trying to do. So we can be biased in that we are purposely trying to mislead what we're doing, or it could just be biased in that when we don't do something that's random, we're not giving everyone an equal chance to be part of this. So then it's not going to accurately be able to represent the population. So whether we are purposely or not trying to do something that will give us the results that we want, if we are not giving everyone an equal chance to be part of our sample, then we're not accurately representing the population because then we're leaving people out of it. So we're leaving maybe a certain group out of it, whether that be sixth graders because we're not surveying sixth graders for this. Whatever it may be, a biased sample means that everyone does not have equal representation. And whether that means that we are purposely doing it or not, it doesn't matter. We need to make sure that it is unbiased, meaning that it is completely random and that everyone is a representative of a population. And then the other thing that we haven't talked about is that it does need to be large enough. Now, we're not going to really get into that too much, but you guys will learn in the future when you take statistics about how many you do at least need to have to make sure it is unbiased. But it does need to be large enough. If I only talk to two people, can I use two people to talk about what AIS thinks? No, we need to make sure that we have enough that it does represent our population as well. All right. So if something is biased, whether they're purposely trying to do it or not, it's just not allowing us to accurately represent the population because either A, we're not giving everyone an equal chance, or B, we're not using enough people to talk about it, or C, we are purposely picking people that we know are going to favor what we want. All right. And unbiased means that it is pure random, pure luck, pure chance of who is being selected. All those people are part of the population, and that it is large enough that we can actually say, okay, based on what these people are saying, we can extrapolate this data over the entire body. All right. So now we're going to go ahead and get into identifying biased and unbiased samples. All right, so here, identifying an unbiased sample. So you want to estimate the number of students in a high school who ride the school bus. Which sample is unbiased? So the four examples we have are 4 students in a hallway, all students in a marching band, 50 seniors at random, or 100 students at random during lunch. So let's go through these. One, is A unbiased? And this one is no, it is not. Right? And the reason is, in order for it to be unbiased, we have to have a large enough sample. And you only asked 4 students. Yes, it was random. And yes, they are representative of the population. And yes, everyone does have a chance to be part of that sample because you are just picking 4 kids that you see in the hallway. But 4 cannot accurately represent what your high school is. It's just not a large enough of a sample. So that won't be no. All students in a marching band. Once again, this one is no as well because we aren't giving everyone an equal chance to be representative of this sample. We're only looking at marching band. So if you're not in the marching band, you have no chance of being on it. Yeah, this is large enough maybe because we have all the students in the marching band, but it's not at random necessarily with the way they're presenting it to us because we just went to all the marching band students. 50 seniors at random. Yes, this one clearly is at random because it says at random. 50 is large enough for us to say that we can use this to talk about our population. But the reason why this one is not, and it's no, is because we're only looking at seniors. And seniors are old enough that maybe not in Hong Kong, but in other parts of the world that they can drive. So since they're able to drive, our data will be skewed because there's going to be more people who won't even have a chance of taking the bus, maybe because they're old enough to drive. Um, so we're not giving ourselves a chance to really represent the full data or the full school, because we're only looking at seniors. So freshmen, sophomores, and juniors have no chance to be part of it. So they're not equally given a chance. And also, the people we're asking will skew this data because a lot of those students might be old enough to drive. And then here it says 100 students at random during lunch. So yes, this one is. And this one is because we know that 100 is definitely going to be large enough. They're at random during lunch. Everyone will be eating at lunch at some point, and it is at random. So everyone has an equal chance to be selected for this, and we're not just picking people who aren't old enough to drive, meaning that the data will be skewed that, yes, of course, they're going to be taking a bus, or that they are old enough to drive, that it will be skewing our data as well. All right, so the only one of this that is unbiased would be D. What you need to be able to take away, though, from unbiased and unbiased samples, and this is really, really important, like when you progress in the statistics, is the results of an unbiased sample are proportional. We learn what proportional means, meaning that they're moving at the same, that they're, we want to talk about the rate of change, we want to talk about that, or like how many people say yes to this versus how many people say no. The results of an unbiased sample are proportional to the results of the population. So as long as if we're taking an unbiased sample of the population, we're able to actually use that data to then make predictions about the population because it has been shown that they are proportional. Whereas biased samples are not representative of population, so we can't use them to make predictions because they are not proportional. And we're not able to say that we can, because we're not giving everyone equal chance or equal voice, or maybe it's just too small, whatever it may be, or maybe we're purposely trying to skew it. So we can't use biased samples data to accurately represent what a population might want, whereas when they're unbiased, they do actually work and move as proportions, meaning that we can use that to make inferences or conclusions about the population. All right, so we're going to now determine whether or not the conclusions are valid. So you want to know how the residents of your town feel about adding a new stop sign. Determine whether each conclusion is valid. So for the first one, it says you survey 20 residents who live closest to the new sign. 15 support the sign and 5 do not. So you conclude that 75% of the residents in your town, the whole town now, will support the new sign. And this one is not valid. And the reason why it's not valid is because you're only surveying people who live closest to the sign. So of course, these people are going to have a different opinion on everyone in the town because that's affecting them more than what it will for someone who lives miles away from it. So they're going to have more of an opinion on it, first off, and their opinion might be that they want that sign, as it clearly shows, because it is directly affecting them, because it's really close to them. Maybe they see people flying through that intersection. Maybe there's been some accidents, and they are directly feeling the impact of not having that stop sign there. So those people will probably be more in favor of it or have a stronger opinion of it than everyone else. And since you're only talking to the people closest to it, you're not accurately representing the entire town. And you are then saying that your town would support it. So you're trying to use this information to then talk about your town, but you can't do that if you're only picking people who are close to the sign. All right, so we can't actually make that conclusion. Now, this doesn't mean that the sign shouldn't go up or that it should. It's just the conclusion you're making that your town would support it is not valid because you aren't giving everyone in the town equal representation. All right, but for B, it says you survey 100 residents at random. So we have 100, it's at random. 40 support the new sign and 60 don't. So you conclude that 40% of your residents in your town support the new sign. And this one is yes, it is valid. And the reason is 100 is a large enough number. It's at random, so everyone in the population has an equal chance of being selected. And we're not just picking people that are close to or far away from the sign that either may have more of an opinion or less of an opinion. So because this is an unbiased sample, we can then say, a random sample, we can then say yes, that we can actually use this information to say what the population would most likely support as well. So this one is valid. All right, so now we're going to use a random sample, unbiased sample, to actually then make a prediction about a population. So you ask 75 randomly chosen students. So one, we have a large enough sample, randomly chosen, how many movies they watch each week. There are 1,200 students in the school. Predict the number of students in the school that watch one movie each week. So because this is large enough, we're randomly choosing students in the population. Everyone has an equal opportunity of being selected. We know that this is unbiased and it is random. And we said that they are proportional to the population. So that means I'm going to set up a proportion. So we randomly chose 75 students, and 21 of them watch one movie per week. So the ratio of students that watch one movie per week to the entire sample is 21 over 75. So now, remember, it's all about consistency. Consistency. We are going to create a proportion, and now we're going to use the information about all of the students in the school. So in here, our numerator was one movie, and our 75 was a total sample. So now if we're going to make a proportion, we need to be consistent. So the total number of students that we asked is going to be the total number of students in the school, meaning that my denominator will have to be 1,200. And then my numerator will be my variable n. That's what we're trying to solve for, predict of how many students in our entire school could we say would watch one movie. So now we can go ahead and cross multiply to solve. So we get 75n is equal to 21 times 1,200. So 75n is then equal to 25,200. And then we divide each side by 75. And n is equal to 336. So we can then make the prediction that 336 students would watch one movie per week in this entire school. And just like we did with the theoretical and the experimental probability, this isn't 100% foolproof, meaning that if we were to actually do this, 336 would be the one exactly, but it would be really close to it. It may actually be the exact number. It could be far away as well because it doesn't guarantee this. But as you learn and more about statistics, as long as if you are having a large enough sample and it is random and unbiased, it does actually come really close to predicting. And that's how we can do polls for elections, and that's how we can talk about all this information where we don't actually have to poll everyone. We can poll a sample of it. So this isn't saying definitively 336 students, just like when we did the experiment, it wasn't going to be exactly what the theoretical probability was. But because we know that the relationship with an unbiased sample is proportional to the population, that we know that this will be really close to what it really will be. All right. And this will allow for us to then make predictions about a huge population with only needing to take a smaller sample. And by doing that, it's cheaper. You don't have to spend as much money if this was real to then figure out what people would want, and also less time consuming, so that we can get done these surveys faster, which then allows for us to predict this a little bit faster as well. So it's important for us to be able to make predictions of a population using a sample because it is more cost effective and it is more timely as well. All right, so that is it for this video.